Hello and welcome to another exciting session of project management. Today we're going to talk about project schedule, planning and development. So here are some objectives that we need to achieve after we complete this session. First one is differentiating between planning and scheduling. Second is outline the steps to develop a schedule. And then third is understanding how to use top-down and bottom-up approaches to schedule development. The fourth one is understanding logical relationships among various tasks or activities and how to find a critical path in a project schedule and understanding what it means. Finally, we will look at various levels of a work breakdown structure, WBS. Planning versus scheduling. Let's first look at what planning is. Planning for schedule, actually. This planning effort is for schedule development. What is the planning in terms of schedule development? It includes, it starts with defining the activities. First, you need to know what kind of tasks that need to be performed on the project. And that's the very first step, actually, understanding exactly what needs to be done. And in what order, because something needs to be done first, and something needs to be done after that, and something needs to be done after that, and so on. So we need to, in other words, we need to understand the logical sequence, how we arrange those tasks or activities across project schedule, and how those tasks or activities are related to each other. Because understanding the relation will help us how to sequence them. And planning is all about understanding what, how, where, who, what sequence, and when, right? These questions need to be answered. For instance, what will be performed? That means what kind of work need to be performed. Second logical question is, how will it be performed? How this work will be done. And third one is, where will it be performed? Fourth one is, who will perform the work? Need to specify the resource. Fifth one is, in what sequence will the work be performed? It's really important to identify and define the sequence. And finally, when will the work be performed? You need to define start date and finish date for each task. So answering these questions, that is part of the planning for the schedule. Now, scheduling means what we do now, we have a plan. Now we need to put the plan into practice to actually develop the schedule. putting the plan into practice. First, we plan for it. Now we actually use the plan to actually develop the schedule. So what we do here, and also we need to keep in mind that whatever we do in schedule development, we need to understand that earned value management requirements need to be satisfied, because one key aspect of earned value management is to check on the project health in terms of project schedule, right? So what are those requirements with respect to earned value management? We need to define all logical ties, all logical relationships among all the activities. So we have a list of the activities now. Okay, how to rearrange them? What goes first? What goes next? And we also need to specify key milestones and deliverables so that we can understand what work has been done by the time of observation of project health. And obviously, we also need baselines. Project baseline means here it should be schedule baseline, and cost baseline. Schedule baseline we have to create here when we complete the schedule development activity. And for earned value management, no, because earned value management includes checking on the health of the project in terms of schedule and cost. So for that purpose, it requires you to have baseline for schedule and baseline for cost. Baseline means you need to have a reference to compare against. So what we are doing is in earned value management is we are comparing the actual performance with the planned performance. And planned performance is what is in the baseline. Baseline. So basically, when we complete the planning for the project cost and project schedule, what we do is we freeze that planning and we call it a baseline. We establish a reference point against which we compare the ongoing actual performance. So project schedule development is a step-by-step process. We start with listing all the activities of the project. So how we get the activities of the project? It all starts from requirements. So requirements of the project, they are captured, validated, and documented. And then those requirements are translated into overall scope of the project. So the overall scope of the project is decomposed into manageable chunks of work. We call them work packages. And that's the process of creating work breakdown structure. And work packages are lowest level elements of work breakdown structure, also known as WBS. So each of those work packages, they are further decomposed into individual project activities or tasks. So that's the first thing we do, is create a list of project activities. The second step is to sequence those activities. For sequencing, you need to know the logical relationships among them. What should be first, what should be next. In other words, we need to identify what are the predecessors, what are the successors for any given activity. So not only the dependencies, there's two things we need to determine here: the logical relationships and also the dependencies. There are dependencies. There could be mandatory dependency. There could be a soft or preferential discretionary dependency, or dependency because of some external forces. So mandatory dependency is that something must be done first before the other thing can be done. For example, you cannot build a house until you have a ready, your base is ready. So base for the house includes pouring the concrete, and concrete base need to cure, and it should be all dry and ready to walk on and build on. So that's a mandatory, that you cannot start framing or cannot start construction until the dependency is fulfilled. You must have a ready base for the house. So that dependency actually leads to sequencing the activities accordingly. Then, if it's a discretionary, then that also needs to be decided. Discretionary means you have choices and you can use one choice or other. So whatever choice you go with, you need to identify that. And third type of dependency is like external. So if there are a building codes, for example, building codes, city or state laws that you need to follow, organizational policies. So you cannot bypass those, and you must follow those. And you need to like, for example, city requires you to have inspection and done first and seek permit before you do construction. So obviously the permit type of activities need to happen first before you do the construction type of activities. So that's a external type of dependency that you need to fulfill. So those are prerequisite for sequencing the activities. Then we have a logical relationships. Means logical relationships is like what should be. No, there is internal dependencies among the activities. So so when how the work should flow, like activity A finishes, after that finishes, then activity B starts, or they can start simultaneously, or they can start at different times and finish at the same time. So these kind of relationships are called logical relationships. So those need to be defined as well. What is the predecessor? What is the successor? And then you also need to know the duration of each activity. You estimate the duration by using some estimation techniques. We will talk about those, right? So duration of activities, you need to know when the activity will start, when activity will finish, how long the duration is, so those need to be determined. All that information, once you have available, then you can complete your schedule. Another thing is here is, which is implied, I didn't explicitly say that, is that you need to identify resources for each activity. Duration of the activity, it depends on how many and what type of resources are available. So, as I mentioned before, for schedule development, step one is to develop the list of project activities. So this is accomplished by decomposing the work packages again, which is called second level decomposition. So work package is like a summary task in a project, Microsoft project software. If you have used it, the summary task is what work package is. So, and each work package is exploded or decomposed into individual tasks or activities called atomic tasks or activities. For example, you have this planning and procurement work package, and what kind of activities it can be decomposed into. First one is create a project management plan. Second task is capture as is IT infrastructure. And third one is capture to be business requirements. And fourth one, define scope. And these are all hypothetical examples of planning and procurement. So just show that how work package can be decomposed into individual activities. So this is the right hand side. You have an example of a sample WBS. So this is about best management books. It's about writing a book. So the book is project management and introduction. We'll give it a number here, WBS number. So started with the 1, here 1.1. So this is the numbering scheme. That's what WBS uses. Then it's decomposed into next level, writing textbook and editing textbook, publishing textbook. And since this is this is next level layer of WBS, so it is 1.1.1. Second one element is 1.1.2, and third one is 1.1.3. And this first one is further decomposed into 3 elements here: chapter 1, chapter 2, chapter 3, and the numbering. You can see that how the numbering scheme actually continues. So if the parent is 1.1.1, then children are 1.1.1.1, 1.1.1.2, and so on. Similarly, editing textbook, that number is 1.1.2, and that is broken into 3 elements here, and 1.1.2.1 and 1.1.2.2, and so on. So first element, editing chapter 1, editing chapter 2, and 3. So this is all editing type of work. And just to show you that the chapter 1, chapter 2, chapter 3, they are further broken down into lower level elements here. Chapter 1 is broken into project selection, project organization, project planning, and chapter 2 covers budget and cost, and scheduling and project controls. Chapter 3 covers auditing and administrative closeout of the project. So as I said before, so lowest level elements, they are called work packages. So in this case, we have this project selection, project organization, project planning, and these three are work packages for chapter one. And then budget and cost, scheduling, project control. These are work packages for chapter two, and so on. This is how WBS is created. Again, remember that the WBS elements, the lowest level, they are called work packages. So for chapter one, we identified that these project selection, organization, and planning, these are work packages. And for chapter two, project, budget and cost, scheduling, and project controls. These are the work packages. And for chapter three, auditing and administrative closeout, these are work packages. And for editing, you have editing chapter one, editing chapter two, editing chapter three. These are work packages. Okay, so for publishing, I mean, this is the last element on this branch here. So this is this publishing textbook is a work package by itself. Okay. So sequencing the activity. So what we do is by creating WBS, we have decomposed the scope into manageable chunks. And then we have a second level decomposition where we decompose each of the work packages into list of activities. So once we have the list of the activities, we need to rearrange them in some sequence. So how we do that? Because we start with this right hand side table here. You see this this second column here is a task or activity. As you can see, this is a list of activities where we can specify a predecessor for that. Predecessor being the first column of this table. Predecessor means what is ahead of this task or activity. So as you can see in the second column, we have a start. First element, first entry is a start. Okay, start is the start of the project. So what is before start? Nothing, because you start from the start. So here you see the start. This is a graphical representation of all this this table you see here, the right hand side. So start is the point where we start, and there's nothing before that. So this is a dash here, means nothing here. Okay. Now next one is a create a project charter. Create project charter, and again these labels A, B, C, D. These are the labels because it's hard to write the complete description of the activity in this small bubble here, small node. So basically you use label like A, B, C, D, and so on. So create project charter label is A. So label here is A. A is create project charter. So you can see that predecessor for that is start. That means what is ahead of it is start. So start is here. So for A, the predecessor is start. So the way we graphically show that, the tail of the arrow touches the predecessor, right? For any activity. So it shows the flow that start is first, after that A. So start is first, after that is this activity A. Now let's look at the third one, is create a project management plan. And that also follows start, right? Start comes first. So that's activity B. So B here, this one is a create project management plan, and it follows a start. Okay. And you connect this accordingly. So this A and B connected to start this way. So, it flows this way. Now, third one is D, captured to be business requirements. And that follows capture as is IT requirement. And we know that, actually, I missed one, actually. Sorry, I missed one. So let me go back here. Capture C C activity is captured as IT infrastructure. That's a C. C is right here. And you can see that the C follows these two activities: create project charter, create project management plan. Those are A and B. So it follows A and B, and then you connect with arrows like this. Okay, now D. D is capture to be business requirements, right? Which is D right here. And it follows capture as is IT requirement infrastructure. And that was C. So D follows C. So this is how we go through this table and create this diagram like this, which is called project schedule network diagram. This is called project schedule network diagram. So this is the activity, this second column. Third column is the label of the activity. And fourth column is the units of duration of each activity. Duration. It's a unit. It doesn't specify whether it's a week or day or hour or a month, but these are units of duration. Start is just a milestone. So there is no milestone by definition has zero duration because just a point in time. So zero. And similarly, when you close it, the finish is also zero because it's a milestone. Milestones always have a zero duration. Other tasks, they have non-zero duration. You can see that A has three duration. So durations are by the the way the technique that is used notation actually that to write the duration is on top of the node, right? Activity node. So we always write on the top of it. Like two is a duration for C, 3 is for A, 5 duration is for D, and so on. Okay, this is how you sequence the activities. In sequencing, you have to figure out what is the predecessor. If the first column is predecessor, so how these activities are related to predecessors? If activity A if activity A has start predecessor, then for start, activity A is a successor, right? So any activity that follows is a successor. Any activity that leads some activity is called predecessor. That means what comes first is predecessor, what comes after is a successor. That's how we read it. So we always read this project schedule network diagram from left to right, start to finish. So as you can see this, we started with the WBS. So you have a graphical hierarchical structure of the scope broken down into manageable pieces is called WBS. Then we created a activity list, right? And then we sequenced this activity list in some sequence. So what we got is a step. So 1, 2, and 3. 3 is when we have sequenced all the activities based on whatever criteria we followed. Now let's look at logical relationships among activities. Default is finish to start. That means activity A finishes and B starts. That means B cannot start until A finishes. This is a default relationship in a Microsoft project. Opposite of that, about this is like let me give you example actually also before we talk about others. So finish to start, as I said, no, this is most commonly used logical relationships, and that's what most of the activities they go through. The one example is having the base ready, foundation ready before you can build house on it. Before you can start construction of the house, you need to have a foundation ready. So let's say foundation is A and framing is B. It That's how it follows. So foundation must finish first before framing can start. So it's a finish to start type of relationship. And then the last one is start to finish. Start to finish, which is rarely used, and this kind of relationship it doesn't happen that often. So B cannot finish until A starts. B activity cannot finish until A starts. For example, there is a call center and shift B and shift A. Okay, shift B people, they are working, and after shift B people, shift A people are coming to take over. So shift A people come, and shift B people will continue to answer the calls, continue working until the shift A people start the job. So as soon as the shift A people take over and start their work, their shift, then shift B ends. So this is example of this kind of relationship. And let's look at the middle two, finish to finish and start to start. Finish to finish is you want the two activities to finish at the same time. So B cannot finish until A finishes. That means both finish at the same time. As soon as A finishes, B finishes. All right. So if you have to let's say if you need to ship a car with if you need to ship a car, and you need to have a car and the tires all available at the same time, so that it can have a complete solution you can deliver. If A is the car, B represents the tires, you need to have both available at the same time, right? Or other, could be many examples. Other examples could be like you need to build a wall. You need to have bricks, you need to have concrete, all available at the same time. So activity, let's say activity B is making acquiring raw materials, bricks for the construction, and A is getting ordering the concrete. So they both must be available at the same time. Actually, no, this is not the finish one. So I kept talking about the start one. So this is start to start. Sorry, start to start. Start to start is what I'm talking about here. Actually, you need to have both ready at the same time before. My mistake. So I instead of so my discussion was for start to start, not finish to finish. Okay. So let's rephrase this again. So start to start, when you want to start at the same time. So whether it's a car and tires, right? Or whether you have concrete and bricks available at the same time. So you wanna start at the same time, right? So A and B, you wanna order them so that they can arrive at the same time. So finish to finish is when you want to have something completed at the same time, right? When you have something completed at the same time. before you can deliver a house, you wanna make sure that you know your your walkthrough of the house, as well as so as soon as the final step of the basically like painting the house is completed, and then you will walk through also, you know it finishes, and then you would hand over the keys to the owner of the house, right? So you want to make sure the two activities finish at the same time. Let's say another example could be that you have you and your friend, you have to catch a flight uh, from point B to C, and you are flying from two different locations. So you want to make sure that you both arrive means you finish your journey at the same time at point B, so that you can go together. So you want to have finish to finish relationship that a le, you know um, your friend's journey and your journey need to finish at the same time at point B, so that you can start your next journey from there together. So these are some examples of logical relationships among project activities. They are used to sequence the activities accordingly. So this way of diagramming, the way you see that in this diagram here, this is called precedence diagramming method. Okay, precedence diagramming method. There are two ways to represent this. So there is people call precedence diagramming method is typically the activity on node type of mechanism. Activity on node is where activity label is written on the node itself. So blue circles, they are nodes. So activity title or label is written on the node itself, like A, B, C, D, and arrows are connectors. Arrows, they connect, they show the relationship, the logical relationship, and the flow of the work in the project. And there is arrow diagramming method. It's activity on arrow. Sometimes there is a notation where activity label is on the arrow, not on the node, and nodes are used as just connectors. But most common use of the notation is activity on node. Activity on node. So you start the project and go this way to all the way to finish. Activity on node. We should write the label of the activity on the node itself. And this is called precedence diagramming method. You also have to specify when you sequence the activities where you have a lead or lag. So it could be mandatory, it could be discretionary. Okay. So how we see this here? Activity A and activity B. So activity B starts as soon as activity A finishes. So there is no delay, there's no overlap. So this maps to the first bullet here. B doesn't lead or lag A. As soon as A finishes, B starts. Second bullet, this second diagram shows B leads A. So it's again finish to start relationship means A finishes, B starts, but B starts before A is still in progress, and B starts little before A finishes, right? Little before A finishes. So what we have here is we have some overlap. This is used to save time, to shrink project schedule. And we will look at an example of a personal computer lab setup, what it means. And B lags A, where you have the relationship finished to start. So A finishes, then B starts, but there is a delay here. Okay, there is a delay here. A finishes and there is a pause, delay, and then B starts. For example, let's say A is pouring the concrete for the foundation of the house, and let's say it takes 1 week for the foundation, the wet concrete to cure. So you have A finishes, then you wait for a week, let's say 5 working days. Then B starts, the construction on the foundation starts after that. So what we did here is we introduced lag. Okay, B lags A by 5 working days or by 1 week. And this lead thing, we can look at example of a lab setup. So you have 10 computers to set up in a lab, where it takes 1 hour per computer to set up hardware, right? And 1 hour per computer to set up software. So if one person, the hardware person comes and sets up all those 10 computers, taking 10 hours, then as soon as she finishes, then a software person comes and configures all the computers with the software and takes another 10 hours. So total time taken is 20 hours. Is this an optimum way of working? It is not. So what is the optimum way of working? So as soon as one computer is ready with the hardware set up, the software person can start. So the hardware person comes and completes one computer, first computer. Then as soon as she moves to the second hardware setup for second computer, the software person can start. So by doing so, how many hours are saved? 9 hours. So we can finish the entire activity in 11 hours versus originally 20 hours. So that's called lead, introducing lead. The project manager's intent is to find opportunities as much as possible where a lead can be introduced to save time. So precedence diagramming method is a graphical depiction of a schedule activities. It looks like that. You have a start of the project and then you have finished the finish point of the project. So you go through, there are various activities, A, B, C, D, and so on. What happens is, depending on the relationship, once you complete this sequencing exercise, you will see that you have multiple paths to go from start to finish. You always read this diagram from left to right. So how many paths we have now, right? Nodes, these nodes are represented like this. Sometimes people use circles or rectangles. So A, B, C, D, they are labels for the activities. So nodes are activities. So A, B, C, D, And arrows are relationships, show the relationships. The tail is connected to the predecessor, arrow is connected to the successor. Okay, so how many paths we have? First path is start, A, D, G, finish. Okay. Second path is start, B, E, H, finish. And what is the third path? Start, C, F, H, finish. Right? That's how you read this. And this kind of a diagram is used to identify critical path. Well, critical path, let me talk about a little bit. Critical path, understanding critical path is very important for project manager in the project, because by definition, a critical path is the longest path in the project schedule network diagram. So this is the project schedule network diagram. And when you do that, so the duration of each activity is written on the top here. What you do is first you identify how many paths you have. Then you, for each path, you add up all the durations and look at the path of longest duration. That is a critical path. So why it is really important to understand the critical path and do something about it, because the critical path is equal to the duration of the project. That means that if any task on the critical path is delayed, the entire project will be delayed. The entire project will be delayed. So it's important that project manager identifies the tasks on the critical path and works with the task owners to resolve the critical path. Means work with them where the sequential relationship can be changed into some overlap to create some slack or float for each of the tasks on the schedule critical path. So the task on a critical path has no slack or float. Slack or float means some kind of leeway, some kind of flexibility in starting the task or ending the task. If there is no flexibility, then any delay in the task on the critical path will delay the entire project, or it will delay the starting of the follower task. So how is the duration of each task estimated? For schedule development, you need to estimate the duration of every task. So various techniques include expert judgment, published data, alternative analysis, bottom-up estimating, analogous estimating, parametric, 3-point, reserve analysis. So let's look at each one of them briefly. Expert judgment is where you talk to the experts who have been there, done that, other project managers or other subject matter experts. They know what it takes to do some activity. In some of the projects, you can tap into the experts' knowledge and consult them, and they can tell you actually how to, they can help you estimate the duration of the task. And subject matter experts, they know if they have done that kind of work before, how long it should take. You can tap into some published data also. Some of the standard construction activities, for example, city offices, they have some data available. Those state government departments like the Department of Transportation or Department of Water Resources. These kind of entities, they have published data that can be used for various construction activities, how long they should take. Alternative analysis is, where you look at various options, and different options have different you know efforts required to do some work, and you estimate the duration accordingly. Bottom up estimating is where you start from the lowest level of the work pattern structure all the way from activity level. This is used when you don't have references available for estimating, and you need to start from rock bottom. And then you use the process of aggregation to ramp up and go up, ramp up through various layers of the work pattern structure to complete your estimating. So you start with the bottom up, very bottom level at the level of activities to estimate the duration. Analogous top-down, analogous is top-down estimating, where it's opposite of bottom-up. So basically, you have some historical data available. Some activities are done before, and so maybe some projects, similar projects done before. So you can reference the available data from those and simply leverage that. It's called analogous. Analogous means similar historical projects or activities. So you do not have to go from bottom up. You can just at the top level, you can use it and simply leverage that information. Parametric estimating includes unit-based estimating, where you have some unit-related, usually linear, measurement type of data available. Like if it takes, let's say, 3 days to build a 100-feet wall, then how long it will take to complete a 200-feet wall. That kind of estimating is called parametric estimating. 3-point estimating is where you have worst case scenario, best case scenario, and most realistic scenario, and you use the estimates for all these scenarios, and then come up with the weighted average to find the expected duration for it's a statistical technique. It's also called program evaluation and a review technique PERT. And reserve analysis is used for estimating, because this is related to the risk contingency. So this is used to use some padding or cushion or lag for duration, to account for the riskiness of the work. So for example, there is a supplier who has to supply the materials from overseas, and there is a risk of getting delays. So you may want to add additional time to account for the risk of being delayed. So that's and similarly, the same thing for the cost also, reserve analysis. So having some additional amount in the budget. 3-point estimating is, as I said, now you have 3 different types of scenarios for estimating. You have worst case scenario, is called pessimistic, and the most realistic one, and then the best case or optimistic scenario. So this is a weighted average. So the more weight is given to the realistic estimate, it's 4 times the weight for pessimistic and optimistic. So you can see that 3-point estimate we have is this weighted average. You have P plus P means pessimistic, R means realistic, and O means optimistic. So P is basically, P alone means it's multiplied by 1. The weight for P is 1. and 1 times P plus 4 times R plus 1 time O, 1 part of O, 4 parts of R, and 1 part of P. You add, so basically what is average? Average is sum of the parts by number of weights, right? Or number of parts. So P plus 4R plus, so how many, so you have the multiple of that's O is 1, for P is 1, and for R is 4. So 4 plus 1 plus 1, 6, you divide by 6, right? So so that's how this is the weighted average for 3. It's called 3-point estimate. And since this is a statistical technique, you also not only need to look at the mean. This is a mean value. This 3-point estimate is a mean value of estimate, but also standard deviation. And the formula for that is P minus O divided by 6. That means how much is it is plus minus this value, mean value, arithmetic average. So CPM technique, we talked about that before. That's used to figure out the longest path in the project schedule network diagram, because if any task on the critical path is delayed, it will delay the entire project. And it's the same thing where we discussed before, that you have a start to end, various paths you go through to reach from start to end, and you have to identify all possible paths and add up a duration for each of the paths. Then longest path is your critical path. So in this example here, path 3 is the longest path in the network. Path 3 here is 54, and then it's the longest path. And this is the critical path, and float or slack for each activity on critical path is 0. Okay. And if you look at the any activity, actually, any activity, this is a notation is using a rectangle for each activity. This edge of the activity is called early start. This edge is called early finish. This edge is called late start, and this edge is called late finish. That's how we read each of these activities in a project schedule network diagram. So float or slack is the leeway, the flexibility in the start of the activity, or in the finish of the activity. Okay. If there is a slack or float, that means that the activity is not on critical path. If activities is on critical path, the float or slack is 0. Sometimes the values, when you are analyzing the project schedule network diagram, sometimes these values, ES, EF, LS, and LF, some of them may not be given to you. So in order to find float or slack, you need to know these values, because the formula for float or slack is either LS minus ES or LF minus EF. And you can see this, that means because this, assume this is as like a perfect rectangle. A rectangle is where you have opposite sides equal and parallel. So ES minus LS, either this side or this side. The float or slack is a difference of ES and LF, or ES and LS. Okay, so you need to know those values. These are some formulas can be used to determine the missing values, like EF is equal to ES plus duration minus 1, LF is equal to LS plus duration minus 1. And once you have these values available, then you can simply use this relationship to find the slack or float. And the assumption here is that when we say the activity starts on a certain day, let's say this activity B, and activity B, let's look at the activity A actually. Activity A starts on day 1. So when we assumption is that it starts in the beginning of the day, in the beginning of day 1. And when it finishes, because 12 days duration, on the 12th day, it will finish in the end of the day, day 12th. So that's the assumption. Even if you finish like by noon, but you still count it like you took the entire day to finish this activity. Okay, so that's how this formula works here. Okay, so if this activity, so for example here, you know that this start from day 1, activity A, and duration is 12. So what is the day, day when it finishes? So this is EF, right? EF. This is ES. EF is equal to ES plus duration minus 1. So ES is 1. 1 plus 12, 13 minus 1 gives you 12, right? So it completes the end of the 12th day. Okay. This is an exercise to just understand this better. Here, this problem 1 says that for activity A on critical path, ES is 10, duration is 6. Calculate the float of activity A. So this is a kind of trick question here. So you don't have to compute anything here because the question says the activity is on critical path. And by definition, any task on the critical path has a float 0. Okay, the float is 0. You don't have to calculate anything because it's on critical path. However, in a problem 2, you have ES10, LF, it doesn't say it's on critical path. It's ES10, LF35, and duration is 6. Calculate the float of activity B. So when you use these formulas, and what do you get here is EF is equal to 15. So you don't have to go further because as long as you have this, either these two values or these two values, you can just take the difference. That's your float. So since EF is 15 after we calculated it, so then we take the difference, LF minus EF, that's 35 minus 15, and the float is 20. So schedule baselining. So once we have all this work done, planning the schedule, creating the activity list, sequencing them, working through the critical path, resolving that, and estimated duration, and fine-tuning the schedule, then we have done everything possible. And also resource loading, because who's going to do the work and what kind of resources are associated with each activity. Once that is done, then a schedule can be baseline. In a Microsoft project, there is a tab where you can click on to baseline the schedule. What happens is what happens is when you do that in a Microsoft project, your planned start and planned finish for each activity, they are copied into baseline start and baseline finish columns. Because once you baseline, that's your reference. That's your reference to use going forward to compare your actual start and actual finish against. Okay, so baseline is really important, and earned value management requires both schedule and cost to be baseline, because the actual performance is compared against the baseline performance. That's why it's so important. And this baseline is baselines are so important for all the triple constraints. There are baselines. There's a baseline for schedule, scope, and cost. And that's why they are part of the overarching project management plan, and they're all reviewed and um, signed off by the key stakeholders, because these are the pillars of project management baselines. It doesn't mean they are frozen into concrete or something frozen. They are living, they are subject to change. They are subject to change. Obviously, the changes are managed through change control, but they are subject to change. So by definition, a baseline is equal to original plan plus approved changes. So originally, when you first time you baseline your schedule, so that time there are no changes. You have original plan, that's your baseline. So you finish your original plan of the schedule, and that's your baseline. Let's say when the rubber hits the road, when you start using your plans to do the actual work, and you realize that you need more time, and you have no way to live, to complete your work in the schedule you have, and you asking for more time, and the request need to go through change request. And if a change request is approved and you get permission to have longer schedule, and that time that your baseline changes, your baseline gets updated. So basically your new baseline will be baseline is equal to original plan plus approved changes. That's why the definition of baseline is original plan plus approved changes. For reporting purposes, a schedule can be represented in different formats. So there is a way you can, I mean, if you are using Microsoft Project, you can filter the reporting into these formats. So it could be a Gantt chart or a bar chart. Gantt chart is the graphical view of your project schedule, where you have where your each non-zero activities are represented by rectangular bars, and your milestones are represented by diamond shapes. So that is a Gantt or a bar chart. Management, some stakeholders like to see that. And there is another way to report the project schedule in terms of milestones. Milestones are defined as activities of zero duration, and they are a point in time, and they graphically their shape is a diamond shape. So management likes that actually, to see how milestones are being achieved. So this is the another way of to represent a project schedule. The third type is for doing more analysis is a network diagram, project schedule network diagram. There you can dissect the schedule to see the dependencies, to see what kind of slack each activity has, where you can rearrange and optimize your schedule. So this is another way of representing a project schedule. With that, this concludes the discussion on project schedule planning and development and development of the schedule. Thank you.